Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about area under a curve.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals 4 over x squared on the interval from -2 to -1, and we want to find the area under the curve here. So we need to set up this integral. We're going to integrate here from -2, the lower bound, to -1, the upper bound, of our function 4 over x squared dx. So the first step is we need to find what's the integral of 4 over x squared. And that comes out to be a -4 over a single x to the first power. Now we're integrating this instead of the plus c from a -2 to a -1 right there. Okay, and if you need help sometimes with x squared right here, I like to sometimes rewrite this problem here to help me visualize it. 4 times, oops, right like this, 4 times x to the -2 power dx, and that might make it easier to see that transition here. Either way, we have to integrate now from -2 to -1, so we plug in -1 in for x first. -4 over -1 minus, when we plug in -2 in for x, -4 over -2. This comes out to be, well, -4 over -1, it's a +4 plus, or minus, 3 negatives, keep it negative, and 4 over 2 is a 2. 4 minus 2 is 2. And there we have it. Our final answer for the area under the curve is 2. We're given this problem right here. Y equals secant squared x on the interval from -pi to -3 pi over 4, and we want to find the area under the curve over this given interval. First, let's go set up our integral here. We have the integral from -pi to -3 pi over 4 of our function, the secant squared x dx. Well, first we need to figure out what is the integral of secant squared x dx. And that is just a tangent of x, all right, with our rules here. So we have the tangent of x as the integral here, and we're integrating from -pi to -3 pi over 4. Well, from there, we're going to plug in -3 pi over 4 in for x first. So we have the tangent of a -3 pi over 4 minus the tangent of a -pi. Well, simplifying that out, what's the tangent of -3 pi over 4? And that is a 1. Tangent of a -pi is a 0. And 1 minus 0 is good old 1. And there we have it. Our final answer here for the area under the curve is just 1. We're given this problem right here. Y equals the square root of x on the interval from 4 to 5. And we want to find the area under the curve over this given interval. First, we need to set up our integral. The integral here from 4 to 5 of our function, square root of x dx. Not bad. Now I like to rewrite this here so we can see that. I like to rewrite the integral from 4 to 5, but instead of the square root of x, I have it as x to the 1/2 power dx. Personal preference for me and how I like to solve this integral. So what does this integral come out to be? Okay. Well, the integral comes out to be right here. We have, what's this integral of x to the 1/5 power is an x to the 3/2 power multiplied by 2/3. And we're integrating this from 4 to 5. So from there, what we need to do is plug in 5 first in for x, then 4, and we're subtracting them. So we have 2/3, 5 to the 3/2 power, minus a 2/3, 4 to the 3/2 power. And at this point, we're just dealing with algebra. Now, the way I'd like to solve this here, and let me, where's that room? Put it up here for right now. I'm going to pull out the 2/3. So that's just my preference, 2/3 here. And then we have multiplied by 5 to the 3/2 power minus 4 to the 3/2 power. Okay? Well, from there, we simplify this to 2/3 and say on the outside. 5 to the 3/2 power comes out to be 5 square root of 5. If I can write a 5 inside of a square root. And then the 4 to the 3/2 power is just an 8. Gotta have a bracket here if I have a bracket in the front. Then from there we can combine this to be one real pretty big fraction. And we have 2 times 5, the square root of 5, minus 8 over 3. Now if you want to write this as a decimal, this is approximately a 2.12 0. Either way, we have our final answer here for the area under the curve over the interval from 4 to 5, which is 2 times 5, square root 5 minus 8 over 3. We're given this problem right here, y equals a negative cosine of x on the interval from 3 pi over 4 to pi, and we need to find the area under the curve over this given interval. Well, first thing I want to do is find, well, what's the integral of cosine of x? So we have to set up our function here, or our integral, from 3 pi to 4 pi of negative cosine of x dx. Now from here we need to find what is the integral of negative cosine of x, and that is a negative sine of x. So we have a negative sine of x here over the interval from 3 pi to 4, 3 pi over 4 to pi. From there we need to, well, plug in our values. So we have negative sine of pi first goes in minus the negative sine of the first value, 3 pi over 4. Okay? Now we need to simplify this. Well, negative sine of pi is just a negative 0 or 0, right? Plus minus a negative is like adding, so we add here, and sine of a 3 pi over 4, if you can see the 4 there, is a square root of 2 over 2. This just comes out to be, right, adding 0, square root of 2 over 2, and as a decimal, it's approximately 0.707. Either way, we have our final answer here for the area under the curve of negative cosine of x on the interval from 3 pi over 4 to pi is a square root 2 over 2. I hope this video is helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.